As soon as we get close enough and we hit the button, which has spawnflag 8, we see our new HUD element. And we can press it, the door opens, and everyone is happy. All right, so let's start implementing our new way of how buttons work. So we want to have display a HUD element, change the cursor when we hover, when the mouse, the crosshair is facing a button, right? Just a little heads up, on Windows 11 now, and I had to change the properties of the project of the Quake 2 solution. So, and what I did is I used this platform version. So you may have to go into your Visual Studio installer program and download one of those SDKs. All of those should work. I just want to show you specifically which version I use. And I also, and this was important, use a different platform toolset. So kind of a downgrade to Visual Studio 2015. I think 2017 should also work, but I was unlucky to easily compile this with the 2019 and 2022 solution version. I'm pretty sure there is a way of making it work with those platform toolsets as well. I was just using this one, and that made it very easy to compile again. Let's start building a level for our, a test map real quick. So we select a new map, we select Quake 2, and we say the Quake 2 valve format. Actually, it doesn't matter for this tutorial which version of the map we use, because this specifically enhances kind of how textures are mapped onto the polygons. So, and we're not dealing with textures much for this, for what we're trying to achieve. Okay, so now here inside of Trenchbroom, and you can skip forward if you don't need this anymore, but just maybe we build a little room here, right? Nice little room. Okay, maybe like this. We go to entities, and of course we need the info player start. So we kind of position him here. All right. Okay, so now I press Control D to duplicate this, and then I say Alt and use the arrow keys to rotate those brushes, the duplicate brush. Okay, and Alt, pressing Alt and just dragging the mouse, clicking and dragging the mouse can move the brush up and down. All right, just a little reminder how Trenchbroom works, and we're not going to do much in Trenchbroom, no fancy stuff here, so this should be fairly easy. And what I want to do is I want to have a button, right? Because that's the goal. We want to change the way how buttons work, and then maybe open a door. So yeah, maybe make a little opening here, make it maybe symmetric, right? So, and then again, Control D, and then I just move this over. I can also use the arrow keys, left and right, to position those. Maybe the door is a little bit narrow here, so yeah, let's just give it a really nice big door opening here. That I think will work. Control D and position it, move it over. Okay. Nice. Okay, this looks good. This is a little bit too high. Whoops. All right, so this is our door. Of course, the door mustn't be that high. Just do it like this. Control D again. Hold Alt and move it up. So this is kind of the top door, the top of the door frame. And here we do Control D again. Whoops. And now we position those walls as well. And of course we can use the side view here. If that is not visible to you, like you have to move the cursor to the right and then wait for this double arrow thing to appear, and then you can do this, right? Okay. Control D again. Yeah, that makes it actually quite easy to position those. Again, Control D, Alt and arrow key to rotate and position those. Hard to grab those sometimes in this view. By the way, if you forgot how to extend those, you have to press Shift, and that makes it like highlight those walls in yellow for the selected brush. And then you can just like keep pressing Shift and then click and drag. Okay, nice. Okay, then the last thing is like we have to fill this hole here, Control D, and move it up. If we are in this view, right, we can press the space bar to change the viewpoint. Okay, so I think this should be fine. Whoops, almost. Let's close this, move it down to, and then, okay, this is a nice sealed thing here. And yeah, so now I want to make the room, press Control and select all the walls here. So the floor, also this one, right? Okay, and maybe this one as well. Like pressing Control while doing this, and then I think I can just do the bottom, the floor. Yeah, it's selected. Okay, so I can just select all of them and then Control D, then rotate those, and then if we go here, maybe, yeah, I can just move those to the as the neighboring thingy here. Okay, now I have to be careful so that I don't create a gap. So in the original Quake version, right, the engine we work with, actually, there mustn't be any holes to the outside. But in like source ports, several source ports that actually allow those holes, I think. So that's no problem to create geometry that isn't sealed. Okay, now let's see. This is kind of, okay. Just wanted to see if I have accidentally duplicate doors now, and then if I move it over, it would like still be a brush there. All right. So we have that. That looks good. Now give it some color. We go to face and select, I think I just want to have something. Okay, are we the kind of the standard brush for like the sewer level, the mandatory sewer level of shooter games. I don't know. I actually want to have something that is not as dark and muddy. Let's see. Is there something interesting? Oh, that looks scary, right? A little bit, maybe too much for this. I want to have something more neutral then as well. We just go with that now, and we have a floor here, and we have a different color for the door, so that we easily can identify it as such. So maybe go with this. We just have to go and maybe scale it out a little. Okay, this looks fine to me. right? Okay. So, and maybe in the other part here we create yet another texture. All right, have select all of them, all the walls, the floors, the ceiling. Yeah, it's selected. And let's go with oof, scary window. This is probably more glassy. Okay, well, let's go with that. And by the way, I want to extend the door frame outwards. So it, whoops, oh, not that much. So we can identify it as a door frame. And I think that will look a little bit nicer when the door moves up. All right, so this is nice. Let's save this map in our Trenchbroom directory, base Quake 2 maps, and then let's call this. It's called 2 rooms. Whoops. All right, 2 rooms. Save this. And now we actually go to our Quake dev directory. There's Trenchbroom, right? And here we just saved our map inside here. And if you forgot how we set this up, just go back to one of the older videos. Basically what I've, this is also in the repository linked in the description. There's this build bat that just works as follows. It's like, just call this build bat, and then we say 2 rooms. That's without the extension, without .map, and then 1 for yes, please start the engine. So this will compile the map we just built and then copy it over to the engine source code, where if we have right now it's here. You have to like change it to where you have your engine located, right? The Visual Studio stuff and everything. And then we'll copy it over to the base Quake 2 directory, the BSP and the map file, and then start the engine. So that is what we're going to do now. Let's see. We forgot to actually add some lights. That's why it's so dark. So let's go back to entity light, and we put a nice little light here. Move it up a bit and maybe give it some color, right? So that's like, you have to do it like this. Add a new property here, and then we can, I think, isn't there a color checker? Yeah. So maybe we do it green, blue, like a nice blue light here. Okay. Then we put another light in the neighboring room. Move it up a bit and give it a different color. So and add a new property. I call this color. Then automatically it will present me with this tool set, and we make it yellow. Let's see how this works. Okay, let's try this. Okay, so now here we are with the blue light. So we haven't like classified this door as a door yet, so that's why it's doing nothing. And by the way, this is very dark. I just noticed, so we can, I think, the light just boost it like to 1000. Let's see how that looks. Yeah, this is just not the walls and everything. They don't respond well to this blue light, I think. So let's give it yet another color. Maybe actually we just do it like a pig, right? The color of a pig. Okay, I think that's better. You guys can see better what's happening, but yeah. So, and maybe actually these, I don't like how those look, because there's not enough contrast between the wall and the door, I guess. Actually, I don't know if those are part of the original Quake 2 distribution. You may have different textures than I have here. I notice a lot of Quake 2 textures, but I don't know if those rocks are actually part of the Quake 2 textures. Okay, I like this a little bit more because we can have a little bit more kind of contrast between the door and the walls. Okay, and I think it's bright enough. So now we select this door brush, we make a right click and say create brush entity func, and then we say door. And actually I think that's all that's needed. Save it and run the script again. Oh, and now, I mean, it does something, it just moves into the wrong direction, right? So as we want to let the door move upward, we have to set the angle to -1. All these positive values between 0 and 359, like that's probably, or like will be in degrees, they refer to a horizontal movement. So if we set the angle to -1, yeah, then the arrow points upwards. Let's see. Okay, beautiful. So this works, right? Okay, so now we create a new brush entity, a button that lets us open the door. So we just create this button here, make it nice and big, like so. Give it a different brick texture. Maybe something that identifies it as a button. Is there maybe something? Or switch? Okay, there is nothing really. Abort, grid on. Whoops. Maybe let's do something like this. Okay, this is our button now. And we do a right click, say brush entity func button. Or is it button? Yeah, it's here. Okay, so now we want the button, once the button is pushed, we want to let it open the door. In order to do that, we go back to the door, go to entity and give it a target name, and we just call it the door. So, and here we say which entity it should be triggered when we select a button, and that is the door. Okay, and now we see this nice little arrow pointing towards the door. Save it and try it out. Ah, wow, it's even blinking, right? It's a special kind of texture. Okay, so now once we push it, the door is opening. So now, of course, the button, I would like to have it go inside the wall. Okay, let's try this. Let's see what is happening. Okay, this works now. Now the button is going inside the wall. All right, so this is a very standard behavior. Now we want to change the code so that once the crosshair, this little crosshair, I hope you can see that, is hovering over the button brush here, then we get an indicator, like a HUD element, the crosshair changes to this thing, and only when we press a certain key, then the button is activated, and not when we bump into it. Okay, now back into the actual code. So in order to start our map, when we press F5, I mean, we can go into the properties of the executable project and go to debugging, and here we can pass command line arguments, and here we just pass the plus map that means start a map on when the engine starts up. 2 rooms we called it. And then we hit apply and say OK. And when we press F5 here, it should load the room. All right. So this is working. Let's quit this. And where we have to go now is the pclient.c file. And here we find the client think function. And this is called every frame, and it deals with everything the client, like the client is us, the player does. So, and when we scroll way down, we see this touch other objects. And obviously I've stepped through the code with like line by line before in order to know what's going on here. And we see this touch function. And other is just an entity, right? If we hit F12, we can see it's like this addict struct, and it gets assigned. Let's see, somewhere it gets set. Yeah, it's just it gets set here. It gets set here the first time in this loop. There are just these this player move struct. It stores all the entities that can possibly be touched. So we go through them and then we check if a touch has happened. And so this line will get fired when we bump against the button. So if I hit F5 here, then this breakpoint should be triggered as soon as we hit the button. Yeah, see? And then when we can step through this and see what this thing is doing. Button fire, we just saw this function real quickly. Then the logic of the button gets activated. All right, so what we also can do here, and this is the first thing I want to talk about, we need a way to figure out what entity our crosshair is pointing to, so that we can change the HUD element that is displayed instead of the crosshair. So there is a function that is called trace, and trace shoots array, actually a volume, into the world, and it will return entities that we are looking for. So let me type this out real quick. Trace returns a trace t struct that will contain the actual entity in the end that was returned by the function. So if this sounds familiar to you, like with ray tracing, this is exactly what it is. And here you see it takes several arguments. The start, mins, max, which I'm going to explain in just a second. Start is just where we want to start. That is the camera position, actually. We want to start at the camera position to shoot out the ray. End is kind of how far, I guess, this ray should go into the world, like 100 units or 200 units, whatever. Then pass end is something I'm going to talk later. And content mask lets us kind of mask several entities that we are actually interested in. So for example, there is something like mask water that will only return entities that when the ray hits on something that has the water property. All right, so let's just assume we have the cam position at hand. Then we say mins, we pass a null here actually, and I'm going to explain in just a second, as I said, why. And let's just assume as well that we already have that. For this pass end, we just put the entity that is passed to this client think function. And then we can say mask solid, for example. All right. So if we actually hit F12 here, there we can see how this mask is defined, how all these masks are defined. So as I said, you could also just look for water, so it would not return anything when we hit a solid wall, for example. But in this case, solid works well. All right. So let me demonstrate first what those mins and max arguments are. In order to do that, it's best to draw a little picture. So that is what we are going to do. So let me pick a color here. So we have, this is the Z-axis. So Z is up in Quake, right? Then we have here the X-axis and here the Y-axis. So let's say this is the world origin, right? And then what we can do is shoot array, right? This trace function. But this trace is not only able to shoot array, but it actually can shoot a volume. So that looks like this. That is made up of those rectangles, right? And the mins and max are just the extents of this volume here. So this one would be the mins, XYZ for mins, and this one would be the maxes. All right. So this is what you could do. You could pass 2 vectors for mins and maxes, telling you that you actually want to shoot a whole, like sweep a rectangle, which in the end gives a volume into the world. But if we set those to null, mins and max, what will happen is actually it will collapse to array with a start and end position. So maybe I should have taken also blue because this is all right. So all right, and this is just the start, and this is the end. All right. So if mins and max are set to null, like this collapses into array, which is what we want. In our case, like we have the player, right, standing here, like this is the box of the player, and the camera is maybe positioned somewhere here. And so we have to figure out, this is the campus. We have to figure out a way to define this camera position. And then, yeah, well, we just shoot array into the player's viewing direction. So this is actually the view direction. And this would be end. And we can define like where end is by taking the view direction, which is, well, a direction should be a unit vector. So this one is a unit vector, meaning it has length equal to 1. And we can define end by just scaling that unit vector by some value. All right. Which we call length, maybe. Yeah, that's it. So how do we actually find this cam position? That's the first thing we want to do. All right. So make a comment here. Find cam position. Here we need another function, or maybe it's a macro, we'll see in a second, that can give us those vectors I was talking about, like the forward vector, this one, the forward vector, and also, by the way, the side vector, like the right vector, and also the up vector. Okay, this is probably getting a little bit bad to see. So again, this is the forward vector or view direction. This is the up vector, and this is the right vector. So if the player rotates in the world, right, those vectors will change as well. They will rotate with this view direction of the player. So also if the player like looks up and down, like something like this, right? This, well, those will rotate. This will just rotate around itself. And this one maybe rotates a little bit like this. And this one also rotates like back if the player is like looking upwards. Okay, so, and there is a function for that, and that is called angle vectors. Okay, so, and here we have to pass actually the angles that the player is kind of relative to the world coordinates, how far the player has rotated relative to the world coordinates. And well, we need those, and those are actually given by the client struct, and then the player state, which contains the view angles. So those are those angles. And now what this function gives back or fills out for us is the forward vector or the view direction, the right vector, and the up vector I was just talking about. Now we just have to, of course, define or declare those rather. Okay, let's just see, is this a macro or that's, yeah, it's a function. With that all out of the way, we can say vec3 t campus, and right now the campus, well, we declare and define it just as the 0 vector for now. So, oops, my keyboard is off. 1 second. All right. So how do we actually now get the camera position into this variable? Well, what we can do is say vector copy, another function to deal with vectors, and we take the origin of the player. Whoops, sorry. And that is s.origin, and copy it into the camera position. So now the campus has the position of the player, which is the feet of the player, actually. So we have to move the, we have to go up to get to the camera position. And there is actually, it's a very easy way to do this. As we said, up is Z, so this is the third entry in the, whoops, excuse me. The third entry into this vector array. And we just say plus equals end, and then view height, which is actually the height of the camera relative to the player position. So maybe we draw a little picture again. So this is getting more clear. As we have said, we have, those are the world coordinates, X, Y, and Z. And then we have like our player position, or maybe first these forward, right, and up vectors with the angle vectors function. So the first thing we did was, let's say I hope I can draw this kind of, let's say the player has rotated like, wait, this is probably not good to, like the player has rotated a little bit. Whoops. Okay. Okay, this is kind of skewed, but you get the idea, I hope. So then these vectors, so like now the y-axis is pointing like this way because this is the player y. Then this is the player x, and okay, z maybe stays the same, or maybe the player is looking upwards as well, player z. So then we have what we pass into these view angles. What is stored are not those vectors. Stored is the rotation of each axis, right? So the player angle function, and as we've seen here, these angle vectors, these view angles, those are stored in the player struct, and we get the forward, right, and up, which are those vectors here. Like maybe this one is forward, right? This one is up, and this is the right vector. And maybe this one actually shouldn't be parallel to the global x-axis. I actually messed up there. So this should be rather something like this, because the player has rotated. I'm sorry. Oh, I hope I didn't make it worse. No. But I think you get the idea. And then what we did, like this is the player position. This is also stored actually. So if we look back here, we have this s origin, which is this one s.origin. This is the current position of the player. And then we have this view height, which we add to the z component. Whoop, this is maybe the view height here. And this is where the camera is positioned. So now we have the cam position. All right. So how do we actually compute the end vector, or the end, I should say, the end point? Well, we can say vector MA, which lets us multiply a vector by a scalar. So we say campos, this is where we start. Then we say how far or how much we want to scale. It actually says scale here. How much we want to scale a certain vector. Well, which vector do we want to scale? The forward vector. And the result, where do we want to store it in? In end. Oh, we haven't defined end yet, actually. Maybe also declare it as the 0 vector initially. Sorry. My typing is off. Okay, so we start at campos. We go to the direction, we add this vector, scale it by 50 and put it in end. So mathematically, this is just end is equal to campos plus 50 times forward. All right. Assuming, of course, forward is a unit vector, which those are. Okay. Well, that's great. So what do we do with that now? Well, we can actually just check if something was hit by the trace function. So the trace happens here, and now we can check if trace, and I think it is end. So if there's something in it, we just want to print it out. And there is this printf, which prints to the console, or yeah, to the screen. And then we just say hit entity, and then we just print out the class name of this hit entity. All right. And then we close it here. And then we compile it, and it should be good to go. So now be careful. If you just hit F5, Visual Studio will see, okay, you have the executable activated, but if we check where pclient.c is located, it is actually part of the game project. So it won't be compiled if you just hit F5. Also Control B for build is not enough. So you have to press Control Shift and B. That will compile the whole project actually. Don't worry about those errors. They refer to the software renderer, which we don't use anyway. But if I hit F5 now, let's see what happens. Okay, so it says hit entity player. You see in the top left, I don't know. So it kind of works, but it appears that we hit ourselves. So let's fix that. Okay, this was a little oopsie. Of course, we're not interested in end.className. We know what end class name is. It's the player. We want trace.end class name, right? Okay, let's see if this actually works. Let's compile this. Let's see, yeah. Okay, so now we see world spawn, and world spawn is just the, and I hope, I mean, it's a little tiny to the upper left of the screen. I hope you can see that, but hit entity world spawn it says, and world spawn is just the, well, you could say in Quake everything is an entity, so the whole world is an entity. So world spawn is by default always there. So now what happens if we approach this button? Well, probably not close enough. Let's see, we set the forward vector to 50. Oh, func button. Here it changes. So this is 50 Quake units. We have to be that close in order to the array to register and see what happens when we actually, if we go below, like, I just noticed that it's not that accurate, right? Or maybe it is. It's just, I think it is. I was just, maybe we should, in order to test this properly, maybe set this to 200 so it's easier to see that it's actually, the array is actually accurate. So now let's see. As soon as I like touch this button, yeah, it should register the func button, the array, and it changes. So and this should also work with the door, by the way. Yeah, func door, you can see. So everything that is in reach and it has the solid property that will be returned by the array. All right, great. So now we want to change the behavior of the array, or rather we only want to make use of the array when we face a certain entity. And that is, in our case, for now, the button. Of course, you can think of any other entity that should display a different HUD element, right? So, but for now, we want to focus on the func button entity, and for that we can easily achieve that by saying, okay, we want to test what properties this entity we just hit with our array has. So we can use something called the spawn flags. And if we go back to the Trenchbroom editor, we can see an entity, right? There is the spawn flags property. And there are already a few defined here. And in our case, or I just used the spawn flag 8. And you can actually change Trenchbroom, the config files, so that it also displays a certain string here saying like activate on keypress or something like that, right? So we save that, and we obviously have to change for this spawn flag here. So test for it. So trace.end spawn flags, And then we just check if this bit has been set, and then we check for spawn flag 8, right? And close it here, move this one up. So now this hit entity, the message we print out to the screen, should only be visible if an entity has this spawn flag, which is the func button entity right now. So let's compile this. And obviously I have to go into start the script again because we changed something here in the map, right? So we need to recompile and copy it over to the engine. All right, so we say build 2 rooms, whoops, 1. And let's see if this actually works. So right now we don't see anything, no string displayed to the screen, but yeah, when we're close enough, yeah, and we hover over the button, then the hit entity func button string gets displayed. So this is actually exactly what we want. So, and obviously it spams all this, right? Okay. So this was rather easy, right? Now we want to change the behavior of the button. And that is only when we press a certain key, the button will be pressed, and not when we actually bump into it. Upon level load, for each entity, a respective spawn function is being called. Like, for example, if the entity is a func button class name, right? If that string is being read by the engine, the respective func button spawn function is being called. And that we can find that in gfunc.c, right? And if we look for sp func button, that is the function that is being called when the entity is parsing the BSP file. Actually, all the entities are encoded in plain text inside the BSP file. So actually, I think it might be interesting to look at this. So if we go to our base Quake 2 maps, and there should be the 2 rooms map. Where is it? Here. So if we look at this with a hex editor of your choice and we load this, we see a lot of like gibberish at first. We can see the kind of the header or like the version of this BSP file. But the way below here, you can see, yeah, for example, world spawn, right? I was talking before, and each map has this world spawn that is the default entity or the global world entity. And somewhere there should also be the, okay, we have info player start, but we see func door, and there should be func button somewhere. Maybe you see it already, but I don't. That's great. Light, class name func door, angle with all the properties. Here is the func button entity. All right. And it also has this property target, the door, like the angle, everything that we set in the editor, we can see here as well. So the entity parses here all the class names, world spawn, class name, info player start, and so on. And it will call their respective spawn functions and set those entities. So in order to prove that, we set a breakpoint here and start the game. And right at the beginning, we can see entity that should be, yeah, it's class name func button. And it will initialize this entity object. All right. And it does a lot of things here. And somewhere, actually, let's stop the debugger. Somewhere here, there is this button use function. And interestingly, this is not the function that is being called when we bump against the button. It's rather button touch. But as we actually want to kind of activate the button on a key press, I want to have something like a function that is being called or is assigned to use, right? So let's go there. Press F12, and here we see this button use function. All right, and we just copy it. We make our own version. We could modify it here as well, but I actually want to use another use function when the spawn flag 8 is being set. So we call this button use on key press maybe. And here we say, okay, if not other client, that means if this is not by the player itself. So we're not talking about the entity info player start here, but we talk about like the player, the person who's sitting in front of the computer and operating, like having mouse and keyboard in their hands, right? But that usually is the info player start, all right? At least in this Quake game implementation. And if that is the case, if that is not the case, rather, then we just return here. We only want to use this if there is actually someone able to press a key on a keyboard. Okay. So, and here we don't want to actually just say button fire. That is eventually the function, by the way, that is being called, that is actually executing all the logic, like moving the button inside and everything, right? Activator is something I'm going to talk in a second. First, we want to surround those two statements with logic that only executes if a certain key is being pressed. And here we just say if other, and yeah, other, by the way, I should mention that other is the entity that is actually triggering or responsible for issuing this button use on key press function executed on self, and self is the button, right? So you see that as this is C language, there are no classes. So if this was C++ or something, it would look like something like this, func button, which is a class or the button entity, and then it would do something like use on key press, and then just pass other and activator, and get rid of the self thing, because self is the func button. All right, I hope that makes sense. All right, so if other, and by the way, other is an entity and client that is null for all entities that are not the human player. So, but we can check if other client, other client, which is us, right? And we can check certain things here. For example, buttons. There is this button struct or rather maybe field that we can check for flags, and that is, for example, button use. All right. And the button use is just it's just a flag, and this is being set when a certain key was pressed. So let's surround those two actually. All right, and that is all there is to it, really. And activator, I want to talk about briefly. We're not really interested in that right now, but it's important to set. Activator in this case is actually the entity that is responsible for triggering all of it. So I just said other is the one responsible for triggering the like other is the info player start, right? Is triggering the button, the self thing. That is correct, but there is another thing called the activator. It doesn't have that. There could be a chain of activations going on, and activator in our case is just the same as other. Like we are the person, or info player start is the person or the entity that is actually really triggering this thing. So those two in our case are the same for now. But what this does is it will play certain sounds. For example, if you press a key or if you jump, this activator is always like, it's how should I put this? This is like to call functions on the activator, like draw a message to the screen, which is us, for example, like the door has, or the key has activated, and now the door is opening, something like that. Okay, I hope this makes sense. If not, we can maybe dive into that a little further. It's maybe quite interesting, because if this is not set, the Quake engine will try to actually call or dereference excuse me, the self activator, and if this is null, it of course will crash, all right, during runtime, which is not great. All right, so now we just have to see how we actually, like, what button should we press, right, in order to set the other client and this buttons field. Oh, and of course, we don't assign this function to anything, so this is it just lives here and doesn't do anything. So if we go back to the sp func button, we scroll down and here we see this and use button use, and we wanna like use our own, but the button use on keypress function if a certain spawn flag, and that is spawn flag 8 as we've seen before, is being set. So we just check for that. If end, and then we say spawn flags 8, and yeah, I realize 8 is just a magic number here, so we probably should put in a macro or something that says like spawn flag use on keypress or something like that. So, but if that is set, we say end use, we use our own button use on keypress. We assign that function pointer, and otherwise we just do what the engine did before anyways. All right? Okay. So what we want is actually in the pclient function, pclient file rather, sorry. Here we need to say, okay, please call the use function when we're close enough and a certain key is pressed, right? And we can just do this here. We see, okay, we have traced our array and we found an entity here. Then we checked for the spawn flags 8, and hopefully that is true. In that case, we print out the class name of the entity, and here we say, yeah, on the key press, please activate the use function. And we, just in case that the use function is not being set, that it is null, we check for that here. And then we can say trace.end and call it. And as I said, this is the self. So this is the button, like the trace end itself. And as being said before, other and activator in this case are the same, which are the info player start. All right. So now, obviously, when we call use, actually the use button on keypress function is being called. Button use on keypress function is being called because we set it to the use function, to be the use function when the spawn flags number 8, spawn flag 8 is being set. All right. Now, how can we test if this is actually the case? Well, we can just set a breakpoint here and see when the trace actually registers, that is, we're close enough. Maybe we set this to 50 again. Compile this and run it. So when we are close enough, at least 50 Quake units away from the button, and we actually point on it, then this function should be called. Okay, so this is nice. So let's actually hit F11 and see what is going on here. So you see, oh, obviously we are actually a human, so otherwise we would have returned here. And then it checks if a certain button has been pressed, and we did not. So this actually does nothing. So if I hit F5 again, obviously we're still close enough, so this will just go forever. So we close the debugger here. And now this is, I think, kind of fun, because there is already this whole use thing is already implemented. We have to go to our base Quake 2, which, like, there's not only entities like graphics and players and sound and everything present, but there is this config.cfg file. And if we have a look into that, there is all these lines with bind, and the engine loads this config file, and it will just assign all these things to the keys. So, and there is something called use, but it is not, I think, not really. Okay, there is this, actually there is use. Okay, here, bind F. Okay, so I thought this is not set by default, to be honest. So that this line is not present, but apparently it is. Okay, and this is the one we need. So when we press F, then we actually want that the button is activated. And this will be the case, actually. This one will be set, this button's use, when we press F, okay? So we can test this by going inside here, setting a breakpoint here, press F5, okay? And if we press, like, if we are too far away and I press F, nothing is happening. But if we close enough, and we see our, like, the text is spawned again. Yeah, and I press F, then the button will be activated, which is what we want, right? So let's continue here. Yeah, and the door is opening. That is great. That is exactly the behavior we're looking for. The thing is, it also works when we bump into it. But we don't want that. We actually only want the button to be pressed when we actually, like, are close enough and issue a key press. Okay. So let's fix that. And oh, by the way, so as I said, if this is not being set, this, or if you don't find this in your config.cfg file, don't edit the config.cfg file, because this is edited by the engine. If you would use the in-engine menu to assign, like, different keys to other actions, then this file is being written by the engine. So what you'd rather do is go into base Quake 2, where the config.cfg is located, and you create a new file that is called, like, a new text file, and call this autoexec.cfg. All right. So, and all your custom things that you wanna edit in editor are placed here. So you would basically override this here and maybe set this to a different key that is not being, maybe use O, like not really good key for I think. Maybe E would be better, right? But this is already use environment suit. So anyway, we can try this. Actually say E. We don't have an environment suit present anyhow. So let's see if this actually works. Now I've explained all of this and in the end it doesn't work. So now I press F. Okay, it still works. So I thought this shouldn't. E works as well. Okay, so both work in this case. I thought that it is being overwritten. Okay. Yeah, okay. But actually, this is interesting. This is interesting. See, I set this autoexec.cfg. I put this line in here. The engine read that and noticed that, and it automatically added this to when I closed the engine and opened the editor again. It told me the file has been changed. So it added the engine actually added those, and probably not ideal. You want to remove one of those, or like actually use a key that has not been assigned already for that action. All right, so let's fix the behavior of the touch. So we don't want to activate the button when we bump into it. So in order to do that, we go back to the gfunc.c file and into the spfunc button, the spawn function for our func button. And when we look here, button touch, that is the one that is the behavior we don't want to have when we set the spawn flag 8. So what we can do here actually is say, oh, by the way, this is an indicator, like it says this function pointer is only be set to button touch if there is no target name present for this func button entity. So what we can actually do is go into the func button, look into the entity properties, and we set a target name and we just call it the button. Save it like so, build but, and then we say to rooms 1. So now if we bump into it, right, nothing is happening because there is a target name set, and this function pointer, as we just saw, is only set if there is no target name present. Okay, so obviously if I press F, it still works. So this is fine. We could do that just so that level designers or us, we have to know we have to set something here in order to avoid the touch behavior. But maybe this is not ideal because, well, sometimes we want to make it dependent on the spawn flag and not if there is a target name set or not, maybe. So this might not be enough. Sometimes we still might not want to set anything for target name here, right? If that makes sense. So I can just say, okay, and if there is the spawn flag, so and spawn flags 8. So if this is not set, right? So now I clear that again. Oops. Okay. So target name is not set. Recompile that and start it. Yeah. See? And now this one is still, even though there's no target name set, I bump into it, nothing happens, only if I'm close enough and press the key. So we just to be safe, we disable the spawn flag. Okay. And now the default behavior is back. Okay, nice. So one thing I wanted to talk about again was this activator. Where do we have it here? If we look at the button, use, or our new button use on keypress, I briefly talked about the activator previously, and I want to show you where it actually matters. So if we go back into our editor and we create a new button, maybe make it something like a platform that goes down. So I right click and say brush entity, and we make it a button again, and here we set the angle so it moves downwards, and I believe in this case it must be -2. I remembered correctly. So the arrow points down, so we step on it and then the button moves downwards. And we want this button actually to trigger our button that we already have in place. So we say target name, the target is the button, and actually name our previous button that we already have. Name it, where is it? Target name, the button. So now we see this chain of events that are taking place. If we would step onto this button, then this triggers that button, and that button triggers the door. So we save it and give this a try. All right, now we have this button here and we step on it. It moves down. This button gets activated. The door moves up, right? So far, so good. So now, what if we actually activate the spawn flag again, right? That we created. We save it, run it again. We step on this button, nothing happens. So what is happening actually when this button, when we step on it, and we have set a target for this button, which is the button, this one, right? The target name. Then it is not the touch function and also not the button use on keypress function that is being called if there is no spawn flag set, right? It rather is the button use function, and we want to see what actually is an other and an activator. So if we set a breakpoint here at the button use function and start the game, let's step onto the button. Let's see what is in self, other, and activator. Other, activator. So self, let's move this up a bit. Self is class name funcButton. Okay, and we can see here target is the door and target name is the button. We know by those properties that we're talking about this button here because we also set the properties target and target name to the door and the button respectively, right? Okay, so self talks about this one. What about other and activator? So let's go into other here. Here we also have a funcButton, and here we have a target that is called or has the property set to the string the button, which is this one, right? It also is a funcButton, obviously, and the target is the button. All right, so we know that other is this platform button. What is activator? Activator has class name player. This is us. So here you see the chain of commands taking place. So the activator, us, we stepped on the button on this one, and this one triggers this this other button, which will eventually call button fire and open the door. All right. Now we would like to actually get our behavior back if we set, or like keep this behavior rather, if we set the spawn flags again. So set it to 8. So we get our added functionality back so that we can activate it on a key press. We save it and just compile it and copy it over to the engine directory. So now as this spawn flag has been set again, this function should be called, right? So let's create a breakpoint here, start the engine. All right, so now if we step on this button, the use function for this button is being called, which is the button on use on key press again, because we in the spawn function for the button, we set it to be this function, right? If the spawn flag is set to 8. Okay, so let's see. We step on it. All right, so as the button moves down and reaches its destination, this function is being called. And let's see what is in self. Yeah, that's just a func button as we expected. It's this one, right? Because as we see again here, it's the door and the button as target and target name. So other now is func button again, which is the platform as we see here, because it has set the target property set to the button, right? Okay, so as other is an entity other than the player, client will be null. This is kind of the way the engine handles to check if it deals with the actual human player, as stated before. So if we look at actually other client, where is client? Maybe just type it out. It's null, right? So if we hit F10, it just goes into return and nothing happens. So what we could do here to make this work is if we check if other is actually the same as the activator, right? Then we know it must be the human player. Okay, so let's check that. If other is activator, then we actually do all that. That means human player, and else we just delegate the whole function to button use and just pass self, other, and activator. All right, and if we compile this, make the breakpoint here and press F5. Okay, so now let's step on it. Okay, here we are again. And let's see, other, right? Which is, again, the func button. But activator, rather, is, let's remove this, activator is the player. So now we are in a situation where the activator is different from other. Like the human player activator, we stepped on the button, but other is actually the one who is responsible triggering the use function for self. Press F10. So this fails, right? Because it's different. And we go into the else branch, and if we press F11, button fire, and yeah, we get our behavior back that was previously there without the spawn flag being set. So remove the breakpoint and let's see it actually in action, the whole thing. Okay, step on it, button is being pressed, door moves up. Likewise, the other version still works, right? We need to get close enough. our trace finds the other entity, like this button. If I press the F key, I can open the door. Okay, that's perfect. So now all that is left to do is change the cursor from the crosshair to some very distinct HUD element, so that the human player who's playing our game knows that he or she can interact with the button. All right? Okay, so let us find the function that is responsible actually for drawing HUD elements. And I think the most reasonable way to go about this is just check what we already have. So we search the code base for anything that looks like a HUD element, or is named rather as a HUD element. So we have the crosshair, we have numbers for health, and we have this item button that is the gun that we are currently have in our hand. And obviously, I mean, I did this before, I recorded this video, but I wanna, instead of just showing you where to jump, I wanna kind of show you the thought process I had while figuring out how the engine draws these things. So for example, with the crosshair, I just press Ctrl-Shift-F to search the whole code base. And for example, we search for crosshair because that is the first thing that kind of is what that is basically what we want to change, right? So find all, and we're lucky. A few things pop up here. And now there is this seal view, there is seal screen, even in menu there is something, and that is probably because we can change the crosshair, like how it looks. Let's actually start the engine and see in the menu what we can do here. If we go to maybe options, free look crosshair. So here's cross, we can say it should be a dot, an angle. Okay, let's go with the angle, and I think just set it to go out with escape. Okay, now we have an angle. It's pretty tiny actually, it's in red. Yeah, okay, so that's probably that, and go here again. So where we have to start is the seal view, and yeah, there is a function, screen draw crosshair, right? And let's see if this is actually called somewhere. Okay, here. Wow, that's a long one. In render view. So this one apparently is responsible for rendering everything that is kind of the players, all the players' HUD elements, I guess. But now, like, I want to focus on the screen draw crosshair function. And if we go inside it with F12, we can see that the refresh module, and in our case, that will be this one, the refgl, the OpenGL renderer. A function is called inside this module that is responsible for drawing a crosshair pick. And if we set just a breakpoint here and press F5, we can see, if we say, let me just clear all of those so it's not confusing, crosshair pick. So this is just a string, right? CH3, probably for crosshair, short for crosshair 3. If we press F11, then there is this draw find pick, and it's probably just trying to find the resource from the PK files, right? And OpenGL calls that actually are responsible for drawing it in the end. So this one, yeah, it makes sense. So if we also check where this file is located, it is in the GLDraw C under refgl in this project. So it belongs to the OpenGL DLL. Okay, but I also want to check what is draw find pick. We just jumped over that, so let's go there. This draw find pick. Okay, so yeah, it finds the full path of where this image is located, and yeah, just as printf, that's the Quake version of the clibs standard function as printf, where it composes a final string out of two other strings. And here it's like pix/ch3.pcx. That is the file that is being pulled from the database. So we just remember that, close it here, and let's see if we find this asset file, the ch3.pcx file, inside the pk database, like in the resource file, right? In order to do that, we go into the base Quake 2 folder, and here is the pk0, pk1, pk2, and depending on what version you have installed, you might have different ones. Like you might only have the pk0 if you only use the shareware version, right? You don't have those. I just, maybe you should do the same. I copied the pk0 pack file and renamed it as .original, so I don't mess with the default one. And you can see by the size count of the kilobyte count that I already messed with this file. Okay. So in earlier versions of this Quake 2 modding series, I recommended the Pack Explorer application to deal with those files. But unfortunately, I had very bad experience with that program now under Windows 11. So I was looking for another one, and that is Packscape. And fortunately, this still works really well. So we start the Packscape and just click on this open folder. And I already located my Quake 2 modding engine stuff and the basic Quake 2 here. If you have not, just navigate there and open the pack0 file. And here we see this file tree, and there is pigs. So we go inside there and we see a lot of PCX files. And in my case, I have linked them with the GIMP program. So you see this funny icon there. Okay, so let's see, there is crosshair 3 PCX. Let us just extract that. We can just drag and drop it out of the Explorer here. And in my case, I use GIMP, and because it is free, everyone can download it and use it. You don't have to pay for it. There's also Sprite, right? But that one is actually a paid program. You can compile it yourself technically, but that is kind of involved. But both Sprite and GIMP are fine. Both deal with those PCX files, in my opinion, well. So if we open that, I say open with just, I want to make sure to open it with GIMP 3. The other one is GIMP 2. We have this ch3 file, right? The crosshair, the number 3, which is the angle that we just saw in the engine, right? If we pull out maybe the crosshair one, because I guess this is the default that we always saw, and also open with GIMP. Okay, by the way, just hold the control key and use the mouse wheel to zoom in and zoom out. You can also press the middle mouse button if it's not a wheel in your case, to translate, and also while keeping control being pressed, zoom in and zoom out. All right, so this is the default one that we always saw, right, during development. And we also have this weird pig or skin tone color, or is it maybe kind of a brick red? I don't know what to make of that. And so this is because there is these PCX files don't store transparency as an alpha channel. Those are indexed 8-bit files. So each pixel has a single 8-bit value assigned. Actually, maybe it makes sense to draw this out. So if you're not familiar or don't remember from previous videos how these 8-bit paletted images work. So we have this PCX file, right? And inside there you have this table. And I'm not drawing the full thing, but this table can store up to 256 entries, right? So we start at 0 here, and then 1 and 2 and so on, right? Until you reach the 256th entry. So, and in this table, you actually store some colors. So maybe, yeah, red and green and blue, and maybe here we have this kind of what was it, the piggy color? I don't know. Actually, it's something, I don't know, like the color we saw here, right? This one. Okay. And like that is part of the file. And then also we have all the pixels, right? Maybe this is a 64 by 64 image. So, sorry, those are supposed to be straight lines. Okay, and obviously it's not 64 by 64, but you get the idea, okay? And in each cell, rather than storing an RGB tuple with maybe encoded each one 8-bit, we store a single 8-bit value. Maybe this one has the value 1. Maybe this one has the value 120. This one has 2. This one has 255, right? And so on. So when the image is parsed, the program has to reference all these cells, all the pixels by this table. So this pixel eventually will be green, and this one, whatever in 120, what was stored here, this pixel will be blue, and this one will have this magic color, right? That makes apparently the Quake engine interprets as transparent. And actually there's something pretty cool about this way of storing images, because what you could do, you could, for example, over time even replace this lookup table with different colors, right? So you don't change anything here. You just change what colors are stored in the table. And you can do this over time. And you get an effect that is called Colorcycling. Okay. And that was used, for example, in adventure games, I remember, during MS-DOS days. Here's one example, right? This is artwork by Mark Ferrari, and he is, I think, a very legendary pixel artist, and I think he was involved in some of the LucasArts adventure games. And this is exactly what is going on here. Those are not individual images that you're seeing here. This is the palette moving. Unfortunately, you can't see the palette updating here. We can increase the speed maybe, stuff like that. But those are the kinds of effects you could achieve, like literal animation stored by just cycling through the color palette. And I think this is also pretty nice. And I think those images are quite stunning and works well still today, right? I think there is even something where it can change day and night. So that was also very, I would say, very common to do, that you had like the same image and you could just represent day, night, sunset, and so on within the same image by just changing the palette. Unfortunately, I don't find the example here right now, but you can imagine that this gradient, for example, could be replaced with the actual colors in the palette could be changed to something more bluish. So it maybe you might think it's more something like noon or something, right? So now back into GIMP. Here we see all these, the palettes. Some of them are actually available by default in GIMP, and you already see that I have added a few. I will just show you how to get this view if you don't see it right now. You go to Windows and Dockable Dialogs, and there you can, I think, there's something called palettes. You just click on that and you will get this view here, right? Okay, so now how do we actually create the color palette so that something like this, right? So that we can pick colors and draw into the picture. We just go to where we have extracted the color map PCX and we import that into GIMP. So we open that here. Okay, we just do a right click somewhere into this list and say import palette. And from there, we should now be able to select the color map PCX image. So we go to image and select the color map, import it, and say import. And here we see a new entry created for us. And we can, I think, we can rename that, and we just call this Quake 2 HUD palette. All right. Okay. So now, whenever we go and create a new image, we say new, and we make it, the new HUD element should be larger. So let's go with 128 by 128. That should be sufficiently large, and click OK. And one thing to keep in mind, this is now in RGB mode. In order to go and make use of this indexed mode or store it as an indexed image, we have to go to image and select mode and say indexed. And here we can actually say what palette we wanna use for that image. And that is important because that palette is going to be stored with the file. So we say Quake 2 HUD palette. That's the one we just created, and say convert. Okay. So if we do a double click into the image of this entry here, we can select actually all the colors and draw with them. So we select the last one here, which we identified as the transparent color, and just create transparent background basically. So you can call this transparent BG. Okay, so it's time to get creative here and create our button use HUD element. For that, I'm going to select the select tool. And if I click on those tools, I can even keep the button pressed, the mouse button, right, and select different versions of that tool. So here, if by default rectangle select is chosen by the program, but I want to use this one. Okay, ellipse. And then make sure that we say replace current selection and not something like subtract or something. Okay. So, and then I can just click and drag. And I think with, if I keep shift pressed, then while dragging, it will make sure it's a perfect circle and not an ellipse. Okay. Also, to be really centered, I'd like to have some guidance. So I can say show grid, right? And now it's okay, this actually kind of works, I think. But I think we can do better and say edit, or rather view and snap to grid. So I can just go here. Oops. Okay, sorry. I'd like to have the controls back. Okay, that's not what I wanted. Okay, Control Shift A deselects everything. Okay, I just do that again. Select the circle and draw it out. Okay, be careful not to click somewhere else, otherwise it will get deselected. Okay, nice. This is what I wanted. So now I can actually put a hole inside the selection we made, and that is kind of, we do that by pressing Control and dragging a circle. And Control and Shift together, again, will make a perfect circle. And you see now that basically we cut out part of our selection. So this part is not part of the selection anymore. Okay, so, and then we just, again, align it so that, okay, I think this is nice. In order to make this a little bit more interesting, I'm going to select the rectangle select tool while having the selection active still. And then I again cut out part of the circle here, of this selection circle. And in order to do that, I keep pressing Control, and you see the minus, by the way, appearing, and like cut out part of it. Okay, so and if I do Control C and Control V, it will apply this cutout, and we can just move this one over and do Control C, Control V again, and move that down here, and Control C, Control V, and move it over here. All right, and then I press Enter, and this whole thing is like applied, right? So now we have a selection, like 4 different parts. Okay, and I'm going to make a new layer. Say okay, and choose a nice color here. I take this yellow one, and I hit Control and comma. And Control comma means fill selection with foreground color. If I do Control point, it fills the selection with the background color, with the other one, or secondary color maybe. Okay, nice. So now I'm actually going to duplicate this layer again, right? Okay, and I say select and grow, and yeah, maybe 4 pixels, maybe 3, maybe 4 pixels. Let's try that, and that will, yeah, as the method or the menu said, it will grow the selection. I actually put it behind the layer with the yellow, with these yellow things here, and I select from the palette the black color, and I say Control comma. This is already looking pretty good, so I actually saved this next to the program packscape, so we easily find it, but you can choose any place you want. And let's call this use button, use HUD. Okay, so this is still in GIMP format, right? And now I'd like to put something in the middle here, like a hand or something. And I was looking through the internet. So for example, I think this one is quite nice. I used this hand, I cut this out and put this in the middle. But as I don't own the license of this image, I can't use that. I also think this one looks quite interesting. It's very distinct, but it somehow reminds me of Nazi Germany. I don't know why. So I'm not going to use that. So I rather photographed my own hand, and I will use that. So as you can see, I just made a photograph of my own hand, and then I cut it out and used that as a base for creating a hand, a pressing hand. And the way I did this is I used basically the magic wand tool here. Just make sure when you do the same, don't make a photo where there is a very harsh drop shadow here, because that makes it hard for the magic wand to select only the hand. So let's see if we get any luck here. As you can see, that's probably not really good. Control Shift A, hello. Okay. So what I did, I was not very successful using just a basic magic wand tool here. So what I did instead is I selected the select by color option. Whoops. Okay, actually selected maybe. And I set it to LCH Chroma. And I'm not quite sure actually for what it stands. Maybe luminance channel chroma, something like that. I just wanted to have something that so it selects by color, because the basic tool I think is by contrast and detects hard like edges, right? And here it gets very fuzzy, especially because there is some of my some hair in the way as well, right? That blurs this line even further. So and by using that tool I was way more successful. Obviously there are certain areas that you have to manually maybe use the rectangle tool and zoom in a little bit and use the plus tool. So this also gets selected. And here on the fingernails and stuff like that, you have to kind of manually go around and fix this. But what you have in the end is this selection here. And what I did is just I created a new layer. And as we did before, set Control comma to select it. This was set to black, or like select a color here, and then you're good to go. All right. And what I did in the end, if I deselect, I just copied that hand over to our already existing image here for the HUD icon, and I just shrunk, I resized the hand, and you can do so by selecting the layer and clicking Shift T, and then you can basically resize the hand. Why is it not showing? I don't know. I set this interpolation method from linear, from cubic to no halo. So, and then that now GIMP refuses to show me a preview here. So yeah, I have no idea why that is the case, but yeah, that is what I ended up with. I think this is a pretty distinct icon. When you're done with that, when you're happy, you go to File and Export As, and we save it as PCX file. I already did this off screen, so I already have it here. So, and then you would just click Export and it will create a valid PCX file. All right, now we have our button use HUD PCX file, and we just drag and drop it into the pics folder of the PK file and then hit save. Okay, so let us just replace the crosshair pic with our own one, and just for testing. So we actually copy pasta those two lines, and we just replace the crosshair pic with the button use HUD. And obviously we replace the width and height of the picture with our own hard-coded, for now, 128 by 128 pixels. Let's compile this and run it. So here we see our new HUD element. That is great. So that seems to already to be working. Obviously, we now want our own function that is being called whenever whenever it makes sense. Okay, so let us just create a new function that draws the HUD, and we call that draw use HUD. So what arguments does it take? Void, nothing. And let's see. Yeah, actually here we just call this piece of code. And we just hard code it here. Okay. Compile that. Okay, that worked. And now we just have to call it. And we go to the place where the draw crosshair is actually being called. So let's see again, where was that? So I set a breakpoint, hit F5, and then just I check the call stack, render view. Okay, yeah, that was that function. I already forgot about that. So we need some logic here that the crosshair should be drawn by default, right? But if we have something like HUD active, or like should draw HUD or something like that, then we want screen draw button draw use HUD, our new function, and otherwise we want the crosshair to be drawn. Okay, and where we can actually set this, there is, if we look closely in CL frame, we have some properties that we can set. And for example, there is this player state field that we're going to look into. Where's player state? Okay, it's here. So because it's part of the frame. Okay, so in player state, we actually, if we go inside there, there is something called stats, right? And here we can, if we look at this max stats, there is some stuff that is being like some flags you can set, right? Like something, stat timer, stat layouts, frags, flashes, chase spectator. And let us just define our own stat here. And we say stat HUD use and set it to 18. Okay. So now if we go back actually to CL view, and where we call the draw use HUD, where we actually call it, we can use it here, and we just say the CL dot frame dot player state stats, and then we check stat HUD use. If that is being set, then we want to draw the HUD and the use HUD, and otherwise we want to draw the crosshair, like the default behavior, right? Okay, the question now is, where is this being set? Well, actually, there is a place for exactly that, and that is in phud.c. And there is a function that is called set stats. Okay. And here we can see that like a lot of these fields, or a lot of these stats get set. So we can also use that in order to set our stat HUD use to 1 or 0, false and true respectively, right? So what we can do is we can do something like a button use, and then we just say if end client, and remember that is the client means is always non-null for the human player. And we can do something like if client show use HUD, for example, then end client, and then we go into this player stat stat HUD use, and we set this to 1. And the default is 0. All right. Well, as you can see now, we have again I just made this up if the HUD shall be shown or not. And this is kind of the same, right? But why are we using this chain? Well, the problem is that this end client is not callable, is not present in the CL view C file. So that is why we go through this indirection of this player state stats field, right? So, but this one in the game DLL, this is always present, and we can just actually go there and add another field here, right? So what we can do is we go to the gclient struct, and we can just here add another field, right? So maybe qboolean show use HUD. Okay, so in order to set this show use HUD to 1, we just go to the pclient.c file where we started basically, right? And where we check if the ray hit something, and if it had the spawnflag 8, then we can just go here and say client show use HUD and set it to true. Okay. And obviously this has to be set to 0 initially, right? That's the default. All right, let's compile all of this and run it. Okay, let's see if this actually worked. It did. As soon as we get close enough and we hit the button, which has spawnflag 8, we see our new HUD element. And we can press it, the door opens, and everyone is happy. This is pretty cool, I think. So I hope this was useful to you and you had fun following along. If you have any questions, or if something is unclear, please let me know in the comments. I am going to try to answer these questions as good as I can. And yeah, I hope to see some new HUD elements in Quake 2 soon. Yeah, take care and see you around. Goodbye. If you liked this video and you want to support the channel, you can do so on patreon.com/pythno. This helps keeping the channel going and producing more videos like this. Thanks a lot.